Hi, my name is Jessica, and I'm here to walk you through how to update your Elasticsearch index using Python and Google Cloud Platform. We will be using Google Cloud Platform's Cloud Functions and Cloud Scheduler to show a method of how to keep our data up to date. Since we will be working with an Elasticsearch index, it allows you to store your data in documents. And while working with an index, your data can quickly grow out of date, especially if you're working with ever-changing data from an API, or any sort of dynamic data set. So to avoid this issue, I'll show you how to create a Python script that allows you to update your index and deploy it using GCP's Cloud Functions and Cloud Scheduler to keep your index up to date. So we'll first set up a Jupyter Notebook to test locally and to update our data once, and then I'll show you how to do this on an ongoing basis with GCP. So we have some prerequisites needed for automatically updating your index. We're going to be using Elasticsearch version 8.1.2, but you can really use any version of Elasticsearch higher than 8.0. We'll also be using Python 3.12.1. You're going to want to go ahead and get an API key for NASA's APIs, since we'll be using one of those as well. And you'll also need to have access to GCP with access to create a cloud function and a cloud scheduler event as well. And then we're going to be using a couple of packages. We're going to be using the request package to connect to the NASA API, pandas to manipulate our data, the Elasticsearch Python client to load our data into an index and keep it up to date. And we'll also be using Jupyter Notebooks to work with our data interactively while testing. And I'll go ahead and show you how to get started installing the required packages. So now I will show you how to install the required packages. So if we do pip3 install request, pandas, Elasticsearch, and Notebook, we should have what we need to start testing locally. So we can see that I already have these packages installed, but this is how I would do it. And then to start my Jupyter Notebook, I can just type Jupyter Notebook, and this will launch in my browser a Jupyter Notebook. So now that we have installed the required packages that we need, from here we can actually get started. So writing some code. So I'm going to walk you through a notebook that I wrote that kind of shows you how to get started updating your data. So the first thing that we're going to want to do is we're going to want to import the request package, which we're going to be using to make HTTP requests to the NASA endpoint. And then from here, we're going to want to be using getPass to keep our secrets and tokens secure. And then from here, we're going to want to be doing, or we're going to want to be using rather, pandas as PD for some lightweight data manipulation. And then we're going to be using the date time module to tell us what day today is and what day 7 days from today is. And then we're going to be wanting to use the Elasticsearch Python client that will allow us to authenticate and connect to Elasticsearch. And then from here, we're also going to be wanting to use helpers, which will allow us to upload our data for the first time. So what we're going to want to do is we're going to run this. And then from here, we can actually create a function called connect to NASA. And this function will pass in a URL for the API that we're going to be using. And that is NASA's NEO endpoint that allows us to get information about about asteroids that come close to Earth. And then from here, we're going to want to pass in our API key from NASA, set today as datetime.now, and then we're just going to pass in the required parameters, which is our API key, the start date, which is today -7, that gives us data from the past week, and the end date will be today's date. And so from here, we can actually just return a GET request as a JSON object to allow us to work with it programmatically. And so from here, we could just pass in this connect to NASA. And then from here, let's paste in our NASA API key. And so from here, we can actually create a data frame. And what we're going to want to do is we're going to put all of our objects into an empty list, and then we'll iterate through it to pass the date and the objects inside of that list. And then from here, what we can do is we can actually allow for some like parsing of nested data with the for loop for the objects in the objects. And then from here, we can actually pass the full part of it, everything that's in the all objects that's been iterated through, pass that into pd.json normalize, which will take our deeply nested JSON data and put it in a pandas data frame, and then it will create a duplicative area for the close approach data, which was our deeply nested data. So we're going to drop that just to kind of create just a nice clean data frame for our data. And then from here, we can actually create our data frame response. And then from here, we can actually check out the first 5 rows. So we kind of can see everything in here. And then lately, I've actually been dropping links.self and Sentry data just because that's unneeded. So we can go ahead and drop that. And then if we do a df.isNull .values.any, they'll let us know if there's any null values that we'll have to take a look at for further data cleaning, but our data set does not have that. So from here, we can actually connect to Elastic. And from here, we're going to be passing in our Elasticsearch endpoint. That's our like host address. And then I'm using Elastic Cloud, but you can also be using a local server, and you just want to put in your endpoint. And then from here, you want to put in your Elasticsearch API key. And this is what we're going to want to be using for authenticating and connecting. And so from here, we can actually just paste in our endpoint and paste in our API key. And then our index name is data loading video YouTube. And so from here, we can actually create our index, and now we're ready to start populating it with data. So from here, we can use a generator that will allow us to map our index name, our ID from our data frame, and send everything to a dictionary just so we can get everything in. And we'll be using that actually to set us up for getting our data into and from our data frame into Elastic. So if we run that, and then from here, we have just uploaded 155 records, and now we're ready to take a look and see when the last time that we have updated our data set is. So we can actually query Elastic to figure out what the last date was that we have inside of our data set. So basically what we're doing is we're going to be doing a max aggregation close approach date to see when the last time we updated our data set is. And then from here, we can actually pass that. We could do some data manipulation and make sure that we take a look at that as a string. And then from here, we can actually just get it in the right format that we can use to work with it programmatically in the future. And then from here, we can actually just print out when the last time that we updated our data set is, and that is actually the date of recording this video, the 23rd of September. And so from here, now we can actually take a look to see when the last time that we've updated our data, and if there is new data, we can actually update that. And if not, we have a couple of statements letting us know that there's no new data to update, or the data frame is none. And I've seen that if there are errors in the past or there was some mistake that happened. So we can actually take a look here. And then we actually see that because we just updated our data set all in one, that there's no new data to update. So now we can actually take a look at our Google Cloud functions. And so from here, we're actually going to start with our function called NASA. This is the function that I use to keep my data up to date on a daily basis. And from here, I can actually click where it says edit if I wanted to edit my function, but we can actually see my cloud pub sub topic that I've created here. And under runtime build and security settings, this is where I would set my API keys and tokens. This is where I set everything that I need for my environment variables. And then from here, what I can do is I can actually write my code just like I would in any other editor. And I can actually do that here in this main.py file. So I have a version of the script running that keeps my data up to date on a daily basis. So it has all of the same imports that we were using before, except for a couple of new ones. So it has import functions framework that allows me to connect to the Google Cloud Functions framework to keep my data up to date. And then I use OS for getting the environment variables that I set in the previous steps. So from here, it should look very similar. I have this function that connects to Elastic and authenticates. And I'm actually using my Cloud ID here, but you can use hosts as well too. And then from here, we can actually connect to NASA. So we have our API URL. We have the same kind of passing in the API key. This should look pretty similar to before. We have our create data frame function. We have the same generator. And then we take a look to see when the last time it was updated. And then we actually have the same function that we'll take a look to see if all the conditions are right and when the last time that our data has been updated, and if there's new data to update based on today's date, then it will update. And if not, it will let us know if there's no new data to update. And then similar to how I've used main functions in the past, I actually have this hello pub sub cloud event that basically ties everything together. So it sets my index name, it connects to Elastic, it prints the last update date just so I know exactly when everything has been updated last. It has my response. And then from here, I connect to NASA, and then I pass in the last update date. And then from here, I print out just the response just to take a look at everything. And then I set my data frame up, and then I have a try and exempt statement just to let me know if there's any issues that arise, and I update my data accordingly this way. I also have this requirements.txt file that has in functions framework requests, Elasticsearch, and pandas, which are really all of the required packages that I need to run this on a regular basis. And then from here, we can actually go to Cloud Scheduler. We can actually see some other updates that I have, but today we're going to be using the NASA update, and we can see that this runs every morning at 8 o'clock in the New York time zone in America. And we can actually see this topic is asteroids. We can see that it ran this morning at 8 o'clock, and it was last updated in February. We can see the next time it's set to run, which is tomorrow at 8 o'clock, and it runs every morning at 8 o'clock. So from here, we can do a force run just to kind of keep our data up to date. I use that a lot just for like if I'm testing or if like I'm making changes to my function, I can actually do that here. So I just ran that, but if I don't manually run it, it will run every morning at 8 a.m. Thanks so much for watching this video. Using Python, Google Cloud Platform Functions, and Google Cloud Scheduler, you now should be able to ensure that your data is updated regularly. This is just one way that you could do this. And you can find the complete code on my GitHub and in the Search Labs notebook as well. And thanks so much for taking the time to watch this video. We have lots of other great video content on our YouTube, and we have lots of other great blogs on our Search Labs site. And as always, if you have any questions, you can let us know on our Discuss forums or our community Slack. Thanks so much for watching today. Have a great day.